QSO Today, episode 191, Mike Bohn, KG7TR. This episode of QSO Today is sponsored by Soda Beams, accessories for the ham that wants to operate portable, radar, or summits on the air, and by QRP Labs, makers of remarkable amateur radio electronic kits at amazing prices. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth, 4Z1UG, your host. I come from a family of builders, mostly in cars and wood, so I recognize craftsmanship when I see it. There are many amateur radio operators who are home brewers and builders. There are also those who operate at a higher level of home building and create amateur radio gear that rivals in function, form, and beauty the commercial radios from manufacturers like Collins. Mike Bohn, KG7TR, is one of those who pays keen attention to detail when he builds tube transmitters, receivers, and transceivers around vacuum tubes. If you're interested in the fine details of home brewing at this level, stay tuned as KG7TR is my QSO Today. KG7TR, this is Eric, 4Z1UG. Are you there, Mike?
Yes, Eric, you're 5x9. This is KG7TR Mike in Sholo, Arizona.
And full duplex on Skype. Mike, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Okay, well, basically going back a couple of years before I got my license, my dad was my Elmer. Now, he was not a ham, but he was an electronic technician during his career in the aerospace industry. And he always worked with radar systems. He got started with radar right at the beginning of World War II, lived in Massachusetts for a year or two working up at Raytheon and then back to St. Louis after the war. But anyway, so Dad worked in aerospace. He was always bringing junk home from work, electronic junk. And right after World War II, he got interested in television also. So he bought a kit version of the famous RCA 630 TS television set. I think his kit was from Fillmore, but it was basically a 630 TS. So he assembled the kit and learned about television. So he ended up fixing people's televisions on the side, kind of a moonlight type job. And I still remember that first TV when I was a little kid. I've seen pictures of it. He never bought the cabinet for it. So he had the CRT resting on some books, and the whole television set was sitting on top of an old radio. And little kids at night, you would peer through the windows because they could see the blue light from the CRT. But so anyway, besides bringing junk home from whatever he could acquire in his job, his full-time job, he had a lot of junk televisions and radios laying around, and he was kind of a pack rat, lots of electronic parts laying around. So I was 10 years old in 1958, and I remember my dad buying me a Heathkit condenser checker, the old one with the dial in the center and the magic eye tube and so forth. And I put that thing together. That was the first Heathkit I ever built. And I was so proud of that when he came home from work. I wanted to show him how well it was working. So that was my introduction to, cutting wires, stripping wires, soldering, and so forth. Around 1959, he bought a Heathkit Thomas electronic organ, and he let me put that together. And that was quite an ordeal because that was, 12 or 13 circuit boards for the tone generators and the amplifier and the keyboard assembly and all of that. So it was quite a job to put that together. I got that working. So then I started to get bit by the ham radio bug. The next Heathkit was an AR3 shortwave receiver, communications receiver, which I put together. And I can remember tuning into a single sideband QSO with that, which was quite a challenge with that bare receiver. But I thought that's pretty neat. I like the way that sounds, and that seems like a pretty neat way to communicate. So from there, my dad was not a ham, but he worked with several guys that were hams. So I bought a copy of the ARRL book. I think it was called Becoming a Radio Amateur or How to Become a radio amateur or getting started in ham radio, something like that. Anyway, it told you how to go about taking the test and getting a license and learning the code. And of course, code was always a challenge for me, but I did manage to get up to about 5 words per minute. And I took a test took the novice test from an associate of my dad's. His name was John Marslack. I'm sure he's silent key many, many years ago, and I don't remember his call. But he gave me the test, and I passed, so I got my novice ticket and built my first homebrew transmitter. It was a right out of the ARRL handbook. By that time, I had bought the actual handbook, and it was a 6A G7 oscillator, and then a 1625 PA tube. And I bought the 1625 for 25 cents at Gateway Electronics in St. Louis. I think they might even still be in business. I'm not sure. They were a couple of years ago, the last time I visited St. Louis. Anyway, it had plug-in coils, and I also built a homebrew power supply, a regulated power supply actually, that used a 6BG6, I think, as the series pass tube instead of a 6L6 or whatever. And then I got a receiver. That was a Lafayette KT200, which was a kit version of their HE10 communications receiver. So that was my station. So that's basically how I got started in ham radio. My first call was Whiskey November 0, Bravo Foxtrot X-ray in St. Louis, Missouri. So that was around 1961 when I had that station set up.
So you were about 13 years old.
I was 12 going on 13. Somewhere in between there, I also picked up an old Admiral television set that I found in a garbage can, a little 7-inch television set, and I actually got that thing working too. So that was another little offshoot of electronics, not necessarily ham radio, but taught me a few things. Learned along the way. Learned from watching my dad. He could kludge almost anything together out of junk.
Well, your mother must have been really something.
We had 5 boys in the family, no girls.
Right.
So as a result, I never learned how to treat women, other than my mother. I never learned, women were kind of a strange thing to me when I was old enough to start dating, because after all, your brother doesn't care if you forget his birthday or whatever,
Your father was an inventor. What did he invent that most of us hams would appreciate?
Well, he was as far as I know, he was the original inventor of the solder sipper. In other words, a vacuum-operated tool that sucks molten solder off of solder joints. And it was around 1957. We were living in St. Louis, and Dad was working at Emerson Electric Company in St. Louis. Now, this is also the Emerson company that made electric motors since the turn of the 20th century. But they also had an electronics and avionics division that made radar sets. So in particular, airborne radar sets. So at the time, around 1957, Emerson had a contract to build the fire control radar system that went in the back of a B-52H model. This H model was the latest B-52 that was in development at that time. And the H models are still flying today. There's about maybe 60 of them that are still in the Air Force inventory. That's the one that had the 8 fan jets on it. It was quite an airplane. But anyway, the fire control radar system in the back of the airplane had a whole bunch of line replaceable modules that were basically aluminum frame type things, maybe 6 by 8 inches. But they used sub-miniature vacuum tubes. So these are the tubes that are about the size of your pinky, and they had eight leads coming out of them, and they soldered these leads to terminals on circuit boards. These were very primitive single-sided circuit boards. Maybe they were double-sided at that time, but anyway, the tube leads were soldered to terminals. And during development, which is what my dad was involved in, since he was a technician building up the breadboards and the prototypes, They had to remove these tubes a lot, as well as other components like resistors and caps and relays. So one of the things he taught me was if you want to remove solder from something and it's light enough, you just heat it up and sling it at the floor, and the solder splashes all over the floor and it's gone.
Wear an apron.
Well, actually,
in case you miss.
The floor in my garage is just covered with little solder splashes everywhere because I still do that. It's easy, but with a prototype module that was probably at the time worth thousands of dollars, you don't do that in a laboratory environment. So he came up with the idea of using a Teflon tube because he noted that solder does not stick to Teflon and Teflon won't melt. So the idea was a Teflon tube, and then you pushed, it was an 1/8 inch diameter tubing, and you push that into a number 2 laboratory stopper, a rubber stopper, and then you push that assembly into a rubber bulb that was used for basting, for like a turkey baster, and then that whole thing became a solder sipper. And then there was a twisted steel wire that you used for cleaning it out. So he figured out a way to procure all the materials, and he made some fixtures and jigs. And we used to make them in the basement. Myself and my older brother and my younger brother made them in the basement. I made thousands of them. And he would give me, I don't know, a nickel a piece or a dime a piece for each component. I think he sold them for $1.50 or so. He was able to sell them to Newark and Allied Electronics and Burstein Appleby at the time. And he also sold them to some manufacturers, for use in their service departments or their production departments. So he was the official inventor of the solder sipper and that principle. Unfortunately, he never patented it, so other people started copying it pretty quickly. But of course, now we have very elaborate vacuum removal tools that actually work better than Dad's solder sipper. But that's the kind of person he was. He could take a pile of junk and make something out of it. So he was definitely my Elmer.
Did ham radio play a part then in the choices that you made for your education and career?
It did. I knew that I wanted to stay in electronics because I really liked fooling around with circuits and making things and building things. So I was in St. Louis at the time, and in St. Louis there were about 3 places you could go to get an electrical engineering degree. You could go to Washington University, $. You could go to St. Louis University, also expensive. Or you could go to the Rolla School of Mines and Metallurgy, which is actually a University of Missouri school. And again, that was room and board, so that would have been expensive. And my parents didn't have a lot of money, but 5 boys in the family. So I ended up going to the University of Missouri at St. Louis instead, and they didn't offer any engineering degrees, but I got a degree in applied physics instead. So it served me well, but I was never actually an electronic engineer or an electrical engineer per se. I never really took those kinds of courses in college.
And what happened after that?
Well, I graduated with my BS in physics in 1969. I was only 20 years old at the time because of a thing in I skipped the 4th grade, and I went to parochial school and skipped the 4th grade. So anyway, I graduated from high school at 16 and college at 20, right into the middle of the Vietnam War. So this was June 1969. The Vietnam War was going on hot and heavy, and the draft was going on hot and heavy. So I got a job at McDonnell Aircraft Company in St. Louis, which is also where my dad was working at the time. And I had expected to get a draft deferment because I had a student deferment all the way through college, and then I was hoping to get an occupational deferment because I really didn't want to have anything to do with Vietnam at that time. It had become obvious to me anyway that it was a no-win situation. But anyway, I was expecting to get a draft deferment, and the first thing they told me my first week there was, you're not going to get a draft deferment because we just lost a huge manned orbiting laboratory contract in our astronautics division, and we got 2,000 engineers that aren't going to have jobs, so we're not going to give you a draft deferment. So Uh, I knew I was going to get drafted, so I started looking into the Navy and the Air Force, as a way to at least become an officer and go to officer candidate school or officer training school. And I ended up taking the Army physical, and they classified me 1A, so it's only going to be a month or two before I actually got drafted. So I started talking to the Air Force recruiter because the Navy said, we can't do anything for you. Air Force recruiters said the only way you can go to officer training school is to sign up for flight training. And this is something I had never thought about in my life. I had never thought about being a pilot. But, it was the only way I was going to get to go to officer training school. And then the recruiter also said, well, we just learned that they're adding another year to your commitment. So your total commitment out of, what you're signing up for right now is going to be 6 years and 3 months, 3 months of officer training school, a year of pilot training, and then a 5-year commitment to fly the line. So I said, okay, whatever, and I signed up for that. And I came home from work on a Friday, and in the mailbox was my draft notice, my greetings from the President of the United States, who at that time was Richard Milhouse Nixon, and also my letter of acceptance from the Air Force. So it was a Friday, and I couldn't get a hold of anybody. It was a pretty awful weekend. But on Monday, I called the Air Force recruiter, and he says, well, you can ignore the draft notice. I will enlist you into the Air Force, into the delayed enlistment program. So that's what I did. And about 3 months later, I was in officer training school. One of the interesting things that happened was the recruiter had said, if you flunk the eye test, you'll become a navigator. Otherwise, you'll become a pilot. Because I had initially said, well, why don't you just make me a navigator? Again, not having ever thought about being a jet pilot. So anyway, I passed the eye test except for the color blindness section. These are plates with colored dots on them, and you're supposed to look at them and see a number, and I couldn't see the number on 2 of the plates. But the airman that was giving me the test traced out the numbers for me and passed me, so that wasn't a problem. I got down to officer training school. They gave me the same test over again. I flunked it again, and they said, well, since you're already here, we're going to give you the test that the Navy uses, which was going in a dark room and looking at a box with lights on it. And I was able to pass that test. Did pretty well in pilot training, surprised myself. I was graduated 7th out of 47 pilots. At that time, the Air Force and the Navy were both cranking out about 4,000 pilots a year. So I got my second choice for an assignment, which was to fly a C-141 transport. I wanted something with lots of motors that was safe, and that certainly fit the bill. So I flew that for about 4 years. The first place I was stationed was Dover, Delaware, for 2 years. And when I was there, I picked up my new call sign, WA3 TKA. Then I was down at Charleston for a couple of years at Charleston, South Carolina. And then they offered me an early out because Vietnam was over. So then I went back to work at McDonnell Aircraft when I got out of the Air Force. A lot of people are surprised to hear me say that flying never really got into my blood, but it didn't. I was pretty sour on the whole Vietnam experience, and I just wanted to get out of the military. So, you never know if you make the right decisions till years later, but I think I did make the right decision.
But you've never flown since.
I took a couple of private lessons after that, in a single engine airplane, just to see if I could, maybe take that up. But it wasn't. I didn't find it to be that very interesting to me. Although about 20 years ago, I got into radio-controlled model airplanes, and I did that for about 20 years. I just gave that up a couple of years ago, and that was a lot of fun. It's it's pretty hard to hurt yourself with a model airplane, other than cutting your finger off or something like that.
Now, you mentioned on your website that you took a 40-year vacation from ham radio. What happened there? I
kind of did. After I got my I should have probably mentioned that I got my conditional license when we were living in Michigan. My dad got sent to Michigan again to work on the the B-52. This was around 1962, and so we moved to Michigan, and I operated up there as a portable 8, and made a few contacts, and not with my novice setup, my homebrew transmitter and my Lafayette receiver. I remember putting up a dipole antenna across the house we were renting. My dad took me out into the woods because we lived pretty close to the woods in Michigan, and we cut down a couple of pine trees, and those became the masts for my full 80-meter doublet. Dug a hole in the sandy dirt and put them in and put a guy wire on them, and that was my antenna when I was in Michigan. And because I was this was in Oscoda, Michigan at Wurtsmith Air Force Base. Because I was more than 150 miles from Detroit, which was the closest FCC examining station, I was able to take the conditional test at the time, and I could barely do 13 words a minute. And another friend of my dad's, who was also a ham, gave me the test for conditional, and I don't really think he could do much better than that either. So he passed me, and I got my conditional and became WA0BFX at the time in Michigan. Then we moved back to St. Louis, and I had a station there. I didn't use it very much because I wasn't much of an operator. I can remember when we were driving from Michigan to St. Louis, we stopped in at Benton Harbor at the Heathkit plant, and I bought myself a DX60 there with some money that I had made cutting grass and so forth while living in Michigan. So I assembled the old DX60, but I didn't use it a lot. And then and I was in high school at the time, and of course I got interested in girls and then cars and so forth, and I didn't really do a lot with ham radio until the late 60s, early 70s when I built a 4-band single sideband transmitter. But that's another whole story that we can get into in a minute. But actually, I started homebrewing radios in earnest around 2009. That's so there was kind of a 40-year hiatus, I guess, if you will, where I didn't do a lot of ham radio work.
Well, you have an amazing website at KG7TR.com. And so I'm going to put that link in the show notes with pictures of the homebrew gear that you build. For the listeners who have not seen the website yet, you build vacuum tube radios that look like rack mount and very military. How did you start down this path?
Well, my first novice transmitter was just built on a chassis, and I don't even remember having a chassis punch. I probably filed the holes out for the tube socket and so forth. And then I mentioned the 4-band single sideband transmitter that I built. That was rack and panel, 7-inch high rack and maybe a 8x17 chassis, which, by the way, wasn't deep enough for what I was trying to do. That was a very ambitious project, and I started on that when I was towards the end of college. It started out as a phasing transmitter, and eventually when I got promoted to first lieutenant, I had a little more money, so I bought a 9 megahertz filter and converted it to a filter type radio. But I guess where I got my ideas for construction came from looking at countless projects in the ARRL handbooks on how people were building radios back in the 50s and 60s, and everybody seemed to do it the same way. It was always a rack panel and a chassis, and then maybe you bought a commercial cabinet for it, or you made a cabinet yourself. So that's how I got started into that. And all the radios I've ever built use Teflon wire because my dad, being in aerospace, always had scraps of Teflon wire laying around. So that's what I use. Teflon wire is probably the best, I think, for homebrew projects. So that first radio was a rack and panel, and then the next homebrew thing I did was to get interested in making sideband transmitters out of old Arc 5 transmitters from World War II. Many people will remember these. They had the two 1625 output tubes and some three octal sockets in the back. I think they had a 1629 Magic Eye tube and a 1626 oscillator, and then they had a plug-in crystal. Anyway, they had several nice variable capacitors on them, and you could use various pieces over again and make yourself a sideband transmitter. So that was in itself kind of made them look like a military radio by using that over again and using the cabinet over again. And from there, the next set of radios I made were called the Octomanias, which you can see on the website. And again, these are rack and panel. I just find the rack and panel and the chassis to be the easiest and best way to make a vacuum tube radio.
And now this message from Soda Beams. The venerable Yaesu FT817 has been the choice of portable operators for a generation. One of its weaknesses, however, is the coaxial power connector on the back of the radio that can be sheared off accidentally when packing the soda station back in the bag. Thanks to a design by John N0WL, Soda Beams offers a power pole accessory connector that attaches to the back of the FT817 with just a screwdriver, protecting the native power connector and allowing you to standardize on the Anderson power pole. In my shack, all of the 12-volt accessories are on Anderson power poles, making it much easier to switch out power supplies and gear. In the field, Anderson power poles remove one level of complication. Soda Beams has a wide range of accessories for the Yaesu 817 and 818, designed for better field operation. In fact, Soda Beams has everything you need to enjoy amateur radio in the great outdoors. When you go to buy anything from Soda Beams' website, pay attention to the coupon code box on the right side of the checkout screen. Put in QSO Today, one word QSO Today, and you'll get 10% off of everything that you purchase through the end of 2018. Soda Beams, amateur radio for the great outdoors. And now back to our QSO Today. I saw an article on the Solder Smoke website where Grayson Evans, his books on thermotrons on tube radios, and I'll refer in the show notes to Grayson's interview in QSO Today. But anyway, he posted pictures of your octal socket radios, and Pete Giuliano's reply was that he was going to throw all of his stuff into the garbage. I thought that was pretty funny, because the stuff you build is really beautiful.
Well, I guess I've always felt that I wanted to build a radio that I would be proud to show off to somebody else. Now, a lot of people make homebrew radios, and some of them turn out just beautiful. And those are the builders and the radios that I always wanted to emulate. Others I've seen at Hamfest and so forth. And frankly, they look pretty awful. And then there's a kind of an in-between mix where the front panel's beautiful, but the radio inside's not so great. And one of the challenges with homebrewing is there's bound to be experimentation, and that's where you run into problems, because if you have to do a lot of rework, then you end up with a rat's nest of wires and components tacked on and extra holes in the chassis and so forth. So it's kind of a matter of trying to plan ahead as best you can, breadboarding circuits where you need to, where you know there's going to be risk. You don't know if it's going to work or not, so you breadboard it up on an old junk chassis first, and I've done some of that, and then taking your time and trying to lay everything out. The old thing about measure it 3 times and mark it twice and cut it once, because you can always cut off more metal if you need to, but you can't put it back if you cut too much off. So you got to think ahead when you're doing that, and then just always having in mind a vision of what you want the final product to look like, and I always wanted it to be beautiful inside as well. The wiring and the soldering and so forth. I wanted it to look like Collins Radio built it. So that was always my goal when I've been homebrewing radios.
So when you are inspired to design a new rig, are you inspired by the parts that you have, by a front panel design that you have in mind? Where do you start?
I almost always start with the acquisition of a hard-to-find part. Primarily, all the homebrew radios I've made have been single sideband. So, because that's always been my favorite radio to make. It's a little bit more complicated than an AM radio, but the circuits are more fun to work with, I think, because there's a lot of low-level stuff in both receivers and transmitters to fool with. So the the radios I have built, let's see, I've built maybe 4 homebrew radios based on the acquisition of a Barker and Williamson phase shift network. Back in the 50s, Barker and Williamson began mass producing their 350 2Q4 phase shift network. It was a octal plug-in tube type affair, and with that phase shift network, you could make a phasing sideband transmitter, which was very popular in the 50s because they were basically simpler than a filter type radio. So if I acquired one of those, I started thinking about what kind of radio can I make with this. And again, my 4-band sideband transmitter that I made back in the early 70s, late 60s, started out as a phasing rig. I remember going down to Walter Ash Radio in St. Louis and buying that phase shift network. I think it was about $6.50 at the time, and that's the one that I used in that radio. Another key component is a filter. If I can acquire a crystal filter and matching BFO crystals, then I can make a sideband radio using that. So those are pretty much the components that I used. Also, acquiring an old ARC-V transmitter. If I managed to grab one of those at a Hamfest, then I could build a radio off of that chassis. And I'd just like to mention, I know there are zealots out there who say you must never, ever destroy an old ARC-V transmitter. And I agree if it's a very, very nice original piece and it hasn't been hacked into. That makes sense to preserve that piece of history and not cut it all up. But all of the ARC-V transmitters that I've used and scrapped out and parted out were junkers. They had already been all cut up and modified because that was a very popular thing to do back in the 50s to get yourself on the air. So they had all been modified and cut up, and so I never paid more than $10 for any of them. So I had no qualms at all about scrapping them out or modifying them for use in a ham radio. And after all, a lot of guys got on the air in the 1950s by doing just that, by taking an ARC-V transmitter and converting it into a sideband transmitter. So again, most of the radios that I've made, it's just gathering a few key components. For example, making a linear amplifier, that usually depended on getting the tubes or the plate transformer, maybe the pi net inductor, and the large variable capacitors. Those are all key components that if I could get those, then I could build a radio out of them.
Now, I noticed that you actually built a power amplifier, but instead of using a traditional plate transformer like you'd find in an old TV, you actually used a toroid transformer. I guess that's a compromise that you're making now. How did that work out?
Well, what happened there was the first linear I built, I called the HB600, and that was built and designed to match up with my Octalmania receiver and transmitter. So that actually uses 572Bs in the output, and it's kind of a clone of a Heathkit SB200 type linear. And for that particular amplifier, I was able to find a great plate transformer from surplus sales in Nebraska. It was a brand new old stock military transformer, put out something like 920 volts at 700 milliamps. So I was able to double that and with a doubler, just like an SB200. And that produces, maybe 2,700 volts, which is great. So then I decided when I built my octal tri-bander transceiver, we'll talk about that in a minute, but I wanted a linear to match up to that. And I always liked 813s because I just think it's a great old tube, a beautiful looking tube. I managed to pick up a pair. And so I went back to surplus sales to try to get the exact same transformer. And of course they were sold out. So as for plan B, someone had told me about the toroid transformers that are available from Antec up in New Jersey. And they're made in China, and they have a 800 volt ampere transformer. It's got two 800 volt AC secondaries. Each one's 500 milliamps. and two 6.3 volt windings at 4 amps each. And it's about a 16 or 17 pound toroid, maybe about 9 inches in diameter. I thought, well, I'll try it. At the time, they were $105, and they fit in a standard U.S. Postal Service mailer. So it was an experiment. And so I got the transformer and tried it out, and it works just fine. But it's a little bit more modern, sitting next to a pair of 813. So you got a 21st century transformer and a 20th century tube, power tubes. But it did work out just fine.
Well, you use the term unobtainium for regarding parts, and I guess those are parts that are no longer obtainable. I've heard that. I think Pete Giuliano also uses that term unobtainium. Are there other unobtainium parts that you're now recomposing in a different way?
Well, of course, the phase shift networks for B&W transmitter or sideband transmitter, those are hard to find. They do occasionally turn up at Hamfest.
I see there's one on eBay right now.
Yeah, you can still get them.
They're still there, right?
They're kind of limited. They'll only give you maybe 32 to 35 dB of sideband suppression of the opposite sideband, which for most practical purposes is good enough. But there are ways to do that using sixth order phase shift networks, and I've built a couple of those, and they're all solid state. They're passive. They're caps and resistors, but those work pretty well. So that's another way to do it. Another piece of unobtainium is if you want to build the cheap and easy sideband transmitter based on an ARC-V chassis, it's hard to find the little audio transformers anymore. These were war surplus, and they're like 20K ohms to 600 ohms. So you use them from a tube amplifier to drive the phase shift networks. Those are impossible to find, but I have built a couple of those transmitters, and I just used cheap little transistor audio transformers from Mauser Electronics. So, a modern part which still works in the same application. As far as most of the other parts that I use in vacuum tube radios, it's mostly I'll call it junk, JUNQUE, that I pick up at Hamfests. I'll see a box of old parts and make an offer and buy them. The parts to make old vacuum tube radios are out there. You just have to kind of search for them. And some of the tubes have become a little bit rare, mostly because the audiophiles have snatched up certain kinds of tubes. But actually, you can find a lot of the octal tubes that I've used for, $2 or $3 a piece, maybe at the most, at ham radio flea markets. So I just start collecting parts, and whenever I see something, it's kind of like, I bet you I could use that someday, and so I buy it.
Do you have a Hamfest or event that you prefer? If you were going to rate Hamfests for finding parts, which one is your favorite?
Well, out here in Arizona, I for many years I lived in the Phoenix area, so there's a Hamfest in Mesa, Arizona, that's pretty good. The Scottsdale Hamfest is pretty good. For many, many years, I used to go to Flagstaff. That was a ARRL Hamfest, and that was pretty good because a lot of people from California would come over. But that one kind of went by the wayside in the last few years, so it doesn't exist anymore. So now I still go to Scottsdale. Actually, let me preface that. I moved to Show Low, Arizona, which is up in the White Mountains of Arizona, where it's pretty cool in the summertime. That's why I moved up here after I retired. I'm about 160 miles northeast of Phoenix now. So I still make the Mesa and the Scottsdale Hamfest. I drive down for those. And lately, I've been going over to the Albuquerque Hamfest that they have at the end of the summer, because that's about 4 hours from here. But yeah, those are the flea markets that I've gone to. Never been to Dayton. People talk about it, but never been to Dayton.
Do you buy parts on eBay?
I have. I don't buy a lot of them on eBay, but let's see. I've bought test equipment on eBay. I've bought air variable capacitors. I bought some tubes, 813s for my linear. And so far, I've had pretty good luck. When I got into the Arduinos, which is another discussion we can have, I bought a lot of stuff, a lot of the Arduino type stuff on eBay.
I think that, your website features mostly the tube gear that you're building, but as you say, you mentioned that you're transitioning into Arduino. Are you using the Arduino as a controller for tube-type radios, or are you going off into a different direction?
Well, the way that came about was, again, the acquisition of a filter. I was at the Scottsdale Ham Fest, and I found a brand new old stock Collins mechanical filter, a sideband filter, 2.1 kilohertz, new in the box. And so I bought it, and I thought, it sat there for a couple of years. I thought, what am I going to do with that? I got to do something with it. So I thought, I think I'll build a receiver, a vacuum tube receiver around that. And I think I'll try to clone a Collins 75S3. Now, I knew right away there were parts of it I wasn't going to be able to duplicate, like the permeability-tuned preselector, because if you've ever seen one, they have all kinds of coils that are wound with nonlinear type windings and so forth, and great big slugs. We've all seen those before. That was not going to be duplicated. And I wasn't going to be able to duplicate a permeability-tuned oscillator like Collins did. So I thought, well, I can probably do the rest of it because I have a bunch of old RF coils that I think will work for the various coils used in the radio. I can probably make a preselector using air variable caps because a lot of the radios from the 50s and 60s that weren't Collins did that. But then I started looking at crystals, and a Collins 75S type receiver has 14 crystals in it. And at the time, you could still get crystals from International Crystal Manufacturing, but they were upwards of $50 a piece. So that wasn't going to happen with 14 crystals. And nobody ever seems to part out a Collins S-line receiver, so I wasn't going to find any crystals that way. So I started, and meanwhile, a friend of mine had said, well, why don't you look at Arduinos? People were using those to control DDS modules. So I thought, I started looking at that. I thought, well, here's an idea. Why don't I get 3 Arduino-controlled synthesizer modules? I use one of them for the first oscillator, which in a Collins receiver is a crystal-controlled heterodyne oscillator. I can use a second one for the VFO, or the PTO, as Collins would call it. And I can use the third one to generate the VFO signals. So for the 3 oscillators in a 75S3, I would be substituting an Arduino type controlled DDS module. And I knew using vacuum tube circuits, like in a Collins receiver, you need about 2 to 2.5 volts RMS of RF to inject into the 3 different, the first 2 mixers and then the product detector. And I knew the Arduino control modules couldn't do that. So I needed to build some kind of an amplifier circuit to make it work, to get it up to the levels where it would work with a vacuum tube radio. So I bought some Arduino modules, and I had never written a line of code in my entire life. So that kind of scared me. I thought, they're cheap and they're inexpensive, and maybe I should try to learn something about this while I still can. So I said, I'll go ahead and buy them anyway and see what happens. So I did that. I bought some Arduino modules. I also bought a copy of a very excellent book written by a friend of mine, and it's called Arduino Projects for Amateur Radio. And it's written by Jack Purdom, W-A-T-E-E, and Dennis Kidder, W6DQ, and I know Dennis personally. Arduino Projects for Ham Radio. Bought the book and started going through it and trying little things with my Arduino modules. I got some LCD displays, and I started out with some AD9850 DDS type modules, direct digital synthesis, and just copied some sketches. I actually got them to work. So, I had them set up on the bench, had my oscilloscope here, and I was looking at beautiful little sine waves coming out of this AD9850, and it would cover all the frequencies that I needed with the typical rotary encoder to change the frequency and the steps and so forth. Got all of that working. And so then I started thinking, well, I don't really need to duplicate the switch selected crystals in the front end of a 75S receiver. I could just have my first oscillator or my first signal source just cover something like 5.6 to 33.6 megahertz or whatever, and I could make a general coverage receiver just using that first oscillator. So I went off on that tack. Then I started working on an amplifier. There are lots of discrete transistor amplifier circuits out there for boosting the output of one of these Arduino controlled modules, but none of them really gave me much output of above about 10 megahertz. If you think about it, you're trying to basically make a wideband amplifier that would be good for maybe 3 to 30 megahertz, and so they just didn't do the trick. So I started looking at current amplifiers, specifically the LMH 6703 type circuit put out by Texas Instruments. Started fooling with that to see if I could get the signal levels up to a couple of volts of RF. And the LMH 6703 is really a wideband. I think it's really intended to be a video amplifier, but it's got like a gigahertz bandwidth, and that thing will oscillate if you just blow on it. So there was a lot of experimentation there to come up with a board layout that would work and be stable, but it did do the job. So my receiver then progressed. All vacuum tubes ended up being 10 vacuum tubes, and 3 of these modules, one for each of the 3 oscillators used in a 75S3. I got the whole thing all integrated and working, and all of the vacuum tube circuits worked perfectly. When I got it totally put together and fired it up for the first time, there were birdies and whistles all over the place. And I wasn't really sure what was going on. Was it bypassing? Was it lead dress? What was causing the problem? Couldn't get it to go away. So I started to do a little bit more internet research, and I found some blogs, in particular a blog by N3QE on noise from these DDS modules. And I discovered that, the carrier is like 60, maybe 50 to 60 dB above the noise products that are caused by the way they generate the sine wave. And when you use that as the first local oscillator in a very sensitive receiver with a lot of IF gain behind it, you're going to get birdies and whistles that you cannot get rid of, because a lot of them are very close to the desired frequency. So that was pretty discouraging. And I tried injecting a signal from my signal generator into that first mixer and got a little bit quieter, but then the second oscillator was also a DDS module, and it created its own set of birdies. So that was the end of the experiments with the 9850. I think what happens there is it recreates a sine wave using a digitally defined sine wave that it runs through an analog to digital or a digital to analog converter. And so you get a bunch of little amplitude steps that recreate the sine wave, and each one of those creates little spurious frequencies that are pretty much unpredictable, and most can't be filtered out. So then I looked at the SI5351 module, and actually for those, that's a different type of synthesizer that uses phase lock loops. They multiply the frequency and then they divide it down using something called fractional division. So I bought some of those modules from QRP Labs and built up a bunch of those that were very inexpensive. They actually create a square wave, and tried that. And again, I used my LMH 6703 amplifiers, which faithfully reproduced the square waves, and got about the same kind of results. So I found out there they also create spurious signals that are very hard to filter out. It's for different reasons. I think it's because of the fractional divisions, where sometimes you divide by 4, sometimes you divide by 5. I don't pretend to understand how it all works, but at any rate, they didn't work so well either. And I even got some low-pass filters from QRP Labs and put them behind the module, thinking maybe the square waves were causing the problems, but no such luck there. The signals were too close to the desired signal. The way I visualized it was the spurs are very close to the desired signal, and the mixer doesn't know the difference between that and the desired signal that you're trying to mix it with. So it spits it right out into the IF, and then you get all these spurs that change. I mean, you can change the frequency by as little as 10 hertz, and the tone sounds totally different. So according to N3QE in his blog, that's definitely the spurs that you're hearing. So it was back to the drawing board for that receiver. I ended up using crystals for the first oscillator, the heterodyne oscillator, and a good old-fashioned vacuum tube VFO with a big old variable capacitor from an ARC-V receiver. And I did still use the Arduino control module for the BFO, because at that end of the gain chain, it doesn't make any difference. There's plenty of signal and spurs are not a problem. So that radio became what I call the 75S2B, which is described on my website, and will also be in next month's edition of Electric Radio Magazine for the old radio buffs that subscribe to that rag. So that was my experience with the Arduinos. Now I do have a frequency counter in that radio, that receiver, that looks at the VFO, and then it offsets the displayed frequency by the selected band and the position of the BFO switch and so forth. And again, what I thought was going to be the worst part of it all was writing the Arduino sketches, the software code. That turned out to be actually a lot of fun and quite interesting, and I was eventually able to get everything to work exactly the way I wanted it to work. I found that actually quite easy to do, because I could just sit here with my computer and revise the sketch, reload it, retry it, and you can just go back and forth. You're not in there clipping wires, unsoldering components like you'd have to do with an analog circuit to modify it. So that part actually worked pretty well, and that receiver's now been completed, and it's totally described on my website. So that's my experience to date with the Arduino systems.
And now this message from QRP Labs. Hans Summers, G0UPL, the ham behind QRP Labs, has created a wide range of radios and radio accessories to make your kit building fun and successful. Over the past few episodes, we have touched on the use of the Arduino microprocessor boards in ham radio projects. Hans created the ultimate Arduino Shield kit that allows you to install this board on an Arduino board, header pins to header socket. With the addition of the SI5351 synthesizer, GPS receiver board, and a low-pass filter, you have a fully automated WhisperNet transmitter. With QRP Labs kits and accessories, there's no stopping the ham that wants to continue to add features, bands, and system capability. What a better way to build a great rig over time on a limited budget and become a master of what's under the lid. For the hands-on learner, this is the best way to become an expert. Be sure to use the links on the show notes pages to get to QRP Labs to tell Hans that you heard it here on QSO Today. QRP Labs is my favorite kit company. It should be yours too. And now back to QSO Today. Do you have any future Arduino plans? I mean, is it going to become a common component in your building?
I don't know. I think a lot of people get into ham radio Arduino for things like QRP, where you can use these little DDS and PLL modules. And I don't want to badmouth these modules, because I think they're just amazing for what they can do. I mean, it's a tiny little chip, and you can create frequencies from a few kilohertz to VHF region, in 10 hertz steps, if that's what you want to do. You just have to make sure you know what the spurs are going to do to you and work around them. And I think they work just fine in QRP projects. I don't know. There are some projects in the book, maybe a Arduino controlled S meter. I don't really know. I'll have to think about that a little bit more. Maybe another frequency counter for a radio. We'll just have to see. I kind of want to take a hiatus from Arduinos for a little while right now.
Do you have a favorite software for building and documentation?
I do. I use Microsoft Visio, primarily because when I was working in aerospace, I used it there to draw schematics and diagrams and so forth. And I learned how to use it at work. And I was able to get a copy of it for home use for $10 from my employer. I won't say who that is, but they're in Seattle, headquartered in Seattle, very close to Microsoft. So anyway, that's what I used, and I use it for drawing primarily schematics and block diagrams. I've sort of built my own library of little symbols for vacuum tubes and crystals and switches and things like that. And once you create a symbol, you can just cut and paste and recopy it over again. So that's what I use for that. And then for writing up technical descriptions, I just use Microsoft Word.
Right. And because you're not using schematic capture to create printed circuit boards, then you don't actually, Visio actually doesn't translate to that, right?
It does not. Basically, most of my Visio schematics are on an 11 by 17 format, which I can shrink down for printing on regular letter size paper. But no, it doesn't translate into anything. I have never actually made a printed circuit board in my life. All of the small module type stuff I have made uses vector board type, breadboarding stock.
Well, I noticed that you use perf board or vector board for replacing slug tune coils because you can't get those anymore, right? So you're using toroids?
That was one way that I came up with for mounting toroids. You're right. When you make these old vacuum tube radios, most of the original documentation you'll find uses slug tune coils, and you can't, even if you could find them, you don't know what the characteristics are. You don't know what the mix is on the slug. You're probably not going to find a bunch of them that are alike. Some of my radios probably use 25 or 30 inductors in them. So, you're not going to find that many that work that are all the same. So I started using toroids because, first of all, they're obtainable. And secondly, they're cheap if you buy them from Amadon Associates. And third, the characteristics are very, very predictable. If you go to the Amadon website, they have a software tool you can download to design toroids. It's called the Mini Ring Core Calculator. And I had found that I can get inductances easily within 10% of the predicted value. So most of the radios I have made use a T50-2 because that seems to work out for HF-type coils and tuned circuits. So I started winding coils using that. And the disadvantages to a toroid are that you have to resonate it with a capacitor, some type of trimmer, and they're kind of awkward to mount. So one of the methods I came up with for mounting a toroid was to take a tiny piece of perf board, maybe a half-inch square, and just mount the toroid to that off of spacer, like a half-inch 632 threaded aluminum spacer. And then you can put bend little pieces of 18 gauge wire, stuff them into the perf board, and those become your connection points. And so you can actually put other components on that little board as well, like decoupling resistors and bypass capacitors and so forth. So you make a little module, and then you just mount that to your chassis and hook it up to your circuits. And also by mounting the other components on the board, now you need less tie strips and so forth in your radio. So that's worked out pretty well using that system, and then using ceramic or air variable trimmers. That's one way to mount them. Another way I've mounted them is to procure some 3/16 fiberglass rod stock, and you can push that rod into a matching rubber grommet in your chassis, cut a piece about 1 inch long, and then you push the toroid down on the other end of the rod, and you can actually build up the diameter of the rod with some masking tape to make the toroid fit nice and tight. And then you could just wire the magnet wire coming off the toroid directly to your circuits doing that. So that was another way to mount toroids. Now on the latest receiver, the 75S2B, I did have a bunch of slug tune coils that I used in that radio. So I did not use toroids in it, but everything else that I've built, at least in the 21st century, has been toroids.
Do you need to spend thousands of dollars to build a machine shop to do metalwork?
Actually, some guys do that. I like to say that my sheet metal skills are in the caveman category. I use a saber saw to cut out big pieces of sheet metal. I scribe everything along a straight edge so I have something to work to, cut it a little bit bigger, and then just file my heart out to get it down to the final size. I don't have a brake press or shear to cut metal or to bend metal. So if I need to make a right angle shield, I have to use angle stock and screws and nuts or rivets to put it all together. It's a very slow process. It's very onerous, and it tends to be very repetitive and messy. But it's if you want to make a vacuum tube radio, you almost have to deal with sheet metal. You're going to be starting with a chassis and working your way up from there.
I don't know if you've ever heard references to the flow state. Do you find that there's something when you're working on metal? I mean, it seems to me that, filing metal, there might be some zen to it. There might be something that, because you're spending a lot of time working on something. Do you find it therapeutic in some way?
Oh, yeah. I mean, I have my satellite radio going, blasting the old golden oldies, and it is good therapy because it's a more of a craftsman type thing. You're actually taking raw materials and turning them into something nice, and you're tapping and threading holes and stuff like that, countersinking and painting and that. So it's kind of mundane, but it is very self-satisfying. Something we didn't talk about was the philosophy behind my Octomania radios. That got started because I was at a Hamfest and I got a whole bag full of octal sockets for $1. And I thought, I'm getting old. It's hard for me to see. Maybe if I should make a radio using octal tubes just to see if I can do it and see if I can make these old tubes work well in a single sideband transmitter. So my Octomania receiver and transmitter was just that. Each one of them uses 12 octal tubes. And if you think about it, well, all of the octal tubes that I've used were designed right before World War II. Now, almost every octal tube has a 7 or 9 pin counterpart. 6BA6 is exactly the same as a 6SG7, which is an octal, and a 12AU7 is very much like a 6SN7 or a 12SN7. So a lot of the circuits that may have been around for the miniature tubes will work just as well with octal tubes. So that's what I did. And when it came time to build the octal tribander, I was on a mission to show that I can build a single sideband transceiver using all octal tubes, the newest of which was introduced in 1952, and that was a 6146. All the rest of the tubes were in production by 1942. And I bet I can make it work just as well as a Collins S-line. And I was successful. This radio works just as well, and it uses all octal tubes. One exception is you can't really get a good RF amplifier that'll work much above 18 megahertz with octal tubes because there's just too much inter-electrode capacitance going on. But below that frequency, they work just fine.
Yeah, but the 6146 was used in VHF and UHF transmitters.
Yes, it was. Yeah, I was talking about an RF amplifier for the receiver.
Oh, I see. Okay.
For the front end, yeah.
Yeah, that would be a lot of amplifier for a receiver.
Yeah, they work fine up to 20 meters, and that's primarily what I did. Well, another reason is the only nets I really check into are on 80 meters and 20 meters. So then the idea was, okay, now I've got a transceiver using World War II tubes. I'm going to make a linear amplifier using 813s because they were designed, get this, in 1938. So they never changed the design of them. So I thought I'm going to get some 813s and I'm going to have a complete station, hollow state, where everything is 1952 or earlier. And by gosh, it works.
Well, that's amazing. Did you have any problems finding the tubes?
No, I've never had any trouble finding any octal tubes. The 6SN7s can get a little pricey. One of the problems you have with octal tubes is it's hard to find tubes with dual sections. The best you can do is a dual triode 6SN7 or 12SN7. But I did have enough 6SN7s. I was able to use them in my radios, but they're pretty pricey, way overpriced because of the audio nuts. But all the other tubes are very, very common and very easy to find. Now, the 813s can get a little pricey if you buy new old stock tubes like I did. I think I paid $140 or $150 for a pair of new old stock Westinghouse 813s, which are in my linear right now. But that's what you'd pay for a pair of 572Bs from China. So the prices are comparable, and these are very, very rugged tubes. Another thing I found is I picked up a pair of Russian 813s, which they call the GL13, and these are back from the Cold War era, made in the late 70s and early 80s. I bought a pair of those and plugged them into my amplifier, and they work just fine. They're great, and they're actually more rugged than the USA-made 813s. So I would say finding tubes for the kind of radios I build, no, it's not a problem. Now, if you want to get into like sweep tubes for output tubes, yeah, they can get very pricey, but you can still get 6146s for a reasonable price. And in my Octomania, I used 6883s, which are the 12-volt version of the 6146, and they're real cheap.
Your front panels are amazingly clean and professional, including the meters on the front panel. How are you labeling these controls? What do you do for that? Well,
again, I use Microsoft Visio, the drawing program, and I make custom meter faces. And something I did not realize, but some Darson-Ball meters have 90-degree movements, and some of them have 100-degree movements. Why, I don't know. But at any rate, so I started designing custom meter faces with that. And then you have to very carefully pop the front case off of the meter and disassemble it. And meters are very, very delicate devices. You have to be extremely careful with the movement, because if you break that little jewel pivot, you're done with that meter. But anyway, you can usually take the front scale off, and it's usually a metal plate, and it'll have something printed on it or silk screened on it from the original. Sometimes you can just turn it over and spray paint the back of it white, and then reuse it. And then I very carefully cut out, first of all, I print out the new meter face on just plain white paper, and then cut it out very carefully and glue it to the front of the meter over the original metal plate, put it back together, and snap the meter case back together. So that's how I do it. I know there's some commercially available software for creating meter faces, but I've never used it. And let me also mention that I always use a laser printer, and I'll talk about why in a minute. But so I'm pretty much stuck with black and white. Some of the meter software that you can get will allow you to print in color, but that involves an inkjet. And I have found over the years that no matter what kind of inkjet printer you have, the cartridges dry out after 6 months, whether you use them or not, and it's very expensive to replace them and very annoying. So I went to laser printers several years ago, just because they don't, the toner lasts forever, and you don't have to worry about it drying out. So that would be the case with meter faces. Actually, I cut out the new face too large, and then I take an X-Acto knife and trim it around the edges of the metal faceplate. So that's how I do the meter faces. As far as the radios themselves, I've done it 3 different ways. I've done the Datamark dry transfers. Most of us remember those from the old days, where you try to find the word you want, and then you very carefully cut it out, and you use a dull pencil and you rub it on. And that works when the Datamark stuff is new, but that stuff dries out after a few years, and then it won't stick, and you can't find it anymore anywhere. So then I went to using a clear label type stock with an adhesive backing, and printed that out on an inkjet at the time, or you can even get LaserJet stock. Then you cut out the little labels very carefully, and you stick them on. And again, it's black and white, so it only works on bare aluminum or a very, very light colored panel. So I tried that, but for the starting with my Octo Tribander, I started using a different system. I used water transfer decals. These are the kind of things that you used when you were a kid, when you were making your little model airplane or whatever. You cut them out, you soak them in a little bowl of warm water, and you slide them off and stick them on whatever you want to use. So I thought, well, I'm going to try that. It sounds cheap. What do I got to lose? So I did quite a bit of experimenting with it. I buy the blank stock from a company called Papilio.com, and the name is on my website. They're in Texas. It's very reasonably priced. You can get 10 letter-sized pieces of blank stock for about $15. And what I do there is I design my front panel labels and also my chassis labels in Visio and print them out on the stock. Now, Papilio sells either laser stock or inkjet stock. You can print it out on either one, but they're not interchangeable. With the inkjet stock, you can print color if you want, but you have to overspray the decal stock with Krylon or something similar after you print it. Otherwise, the water that you're going to soak it in is going to dissolve the inks. With the laser stock, it's runs through a heat process, and so you don't have to do anything with it there. But again, you're dealing with just black and white. Now you can print color laser if you have access to a color laser printer, but I don't. So I use black and white. For all of my decals, I use Visio to draw a border around the outside of them for two reasons. Number one, it makes it easier to cut with a pair of sharp scissors against that border. Number two, it gives you a horizontal or a vertical axis to align your decal with, so you can get it perfectly parallel or perpendicular to the edges of the panel. And a third reason is there will be a transition that you can feel on the panel because the decal does have some thickness to it. And so it makes that transition even and barely imperceptible if you do have that dark border around the side. If you didn't have the border, you'd feel a bump and you wouldn't see a line. And so, it might actually show. You print out the decals using a laser jet printer. And by the way, this whole process is described on my website. Then you prime the panel. I use a very light gray primer from a Rattle Can, Rust-Oleum type primer, available at the big box home improvement store. Spray it on, let it dry thoroughly. Then you very carefully cut out the decal, soak it in warm water, and slide it on. And you just use a paper towel to squeeze out all the bubbles and so forth. And you have to line it up again with the horizontal and vertical axes. For control shafts, I use Visio to print a bullseye right in the center of the circle. And then I line that up over the hole in the panel where the control goes. That allows me to make sure that the circular scale, for example, for a pot, like a gain control, will be perfectly centered around the knob. Then you let the decals dry for about 24 hours. And if it's on a front panel, it's a little trick I learned. It may come out looking kind of splotchy. You just put it in the oven at 270 degrees for about 15 minutes, and it will just slightly melt that decal a little bit, and all those splotches will go away. Then you just overspray the whole thing with some matte finish, again from Rust-Oleum, some clear matte finish. Comes out looking just fantastic. I've displayed my radios at some ham radio events, and people are just in awe at how nice they do come out. And it's actually a very inexpensive process. One ham suggested to me that I try out one of these panel shops. There's a place in California that will allow you to download free software, design your front panel, send the file off to them, and then they'll engrave a rack panel for you, any color you want, with any color you want for the fill. And I thought, that's fine. That would cost you maybe $150 for a rack panel. But if you screw it up, if you make a mistake on one of your dimensions or something, it's on you, and now you've got a piece of scrap metal. So I didn't want to go that route. That might be okay if you if you got an unlimited supply of money to do something like that. But my process works quite well. And I also use it to label the chassis. So I label all of my tube sockets with the tube number, all my coils and pots and so forth on the chassis that are adjustable have little tiny labels. There, I just apply them to the aluminum, clean it with some alcohol first, slide it on, and let it dry, and then I paint it with a brush and some polyurethane finish to keep the keep the label on. Otherwise, they do tend to come off if you don't fasten them down with some kind of paint or something like that. So that's the process.
The point in your process, though, where you're actually doing this labeling and stuff is before you've mounted the parts, right? So you're not putting the whole radio into the oven for 20 minutes.
Oh, no. I mean, basically the radio's built, all the holes are drilled, everything's working. Then you totally remove the front panel. And then I buy bare aluminum panels. You totally remove the front panel, remove everything from it, sand it and finish it, and then put the labels on, bake it in the oven, then you reassemble the radio.
That makes sense. Mike, what excites you the most about what's happening in amateur radio now?
Probably all of the emphasis on home brewing things again that comes from again the very, very inexpensive modules that you can buy. And it seems to be a lot easier for people that make circuit boards to design those and get boards made and kit up some parts that you can do. Like a BitX type radio, something like that. It's a very inexpensive way for people to get into QRP, to get into ham radio. It will probably be of interest to some of the younger kids who we desperately need to get into to amateur radio. As for myself, I'm stuck in a 1950s, 60s type time warp of vacuum tubes and Arc 5 VFOs and so forth. But that I think would be exciting to a lot of people, and it's getting people making things again. That was always the biggest fun for me, was making something, putting it on the air, getting it to work, getting all kinds of kudos and compliments from fellow hams. That was always very, very self-satisfying for me. Making some, knowing that I could do the best that I did on a homebrew project. And homebrewing kind of went away, I think, in maybe the 70s or 80s when the typical transceiver became all solid state and then computerized, and it was so complicated that no one could ever homebrew anything like that. You know what I mean? But at least with vacuum tube circuits, you could sort of maybe kind of duplicate what a commercial manufacturer had done. No hope for that. And then even Heathkits went by the wayside because with surface mount components and so forth, it just became impractical for the average ham to homebrew anything. Now, of course, today it's all surface mount, but you're able to buy, it seems like, smaller and smaller modules and assemble them together and do something with them.
What advice would you give to new or returning hams? Well,
if you've been a ham for a long time and you've ever thought about homebrewing something, and maybe you're retired now and you want to try it, I think it can be done. And I would recommend maybe as a starter, get yourself an old Arc 5 transmitter somewhere and duplicate one of the cheap and easy transmitters that I have built. It's on my website. It's doable. I mean, there's enough information there on the website to actually to make one if you were so inclined. And that would be if you were a guy that remembers vacuum tubes. I'm not sure a young ham today would want to do that, but maybe. For younger hams, again, try to get interested in whatever part of it interests you. I mean, ham radio has so many different aspects to it. Just see what somebody's doing. It's we all know it's a little bit harder to get a young person who's used to picking up a cell phone and calling the other side of the world interested in HF communications. But the fact of the matter is, maybe if it was explained properly to them, hey, you're actually transmitting this one single carrier all the way around the world off of the ionosphere. Maybe if they understood that part of it, they might get some interest in it. But again, there's QRP, computer-controlled radio communications, all of these things that the younger people today would catch on to very easily, and maybe that's what they need to do.
Well, Mike, I want to thank you so much for joining me on the QSO Today podcast. This has been really fun, and in fact, home brewing and building is my side of the hobby too. So I like to talk to people who are doing it, and I'm so grateful that you decided to spend some time with me. So with that, I want to wish you 73.
73, Eric.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Mike. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in KG7TR in the search box at the top of the page. My thanks to both SodaBeams and QRP Labs for their support of QSO Today. Please show your support of these fine sponsors by clicking on their links in the show notes pages or by using QSO Today, one word, QSO Today, in the coupon boxes at checkout. I want to announce that beginning next week with episode 192, ICOM America has become a key sponsor of the QSO Today podcast. I'm very excited by this sponsorship. My very first exposure to ICOM was as a teenager in 1973, when my Elmer, Gary Parks, K6UIM, now a silent key, brought over his ICOM IC230, one of the very first, if not the first fully synthesized 2-meter mobile transceiver. I would sit in his car and try out all the repeaters in Southern California. I have owned other ICOM products throughout the years as well. The most visible representative of ICOM America is Ray Novak, N9JA, who has become a celebrity in the amateur radio media, attending conventions and hamfests, as well as being a big supporter of ham radio to the Boy Scouts of America. I hope to get Ray's ham radio story for the QSO Today podcast in the near future. So I welcome ICOM America and their support of QSO Today. You may notice that some of the episodes are transcribed into written text. If you would like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor, monthly or annually, by clicking on the sponsor buttons on the show notes pages. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, and I've actually put new buttons on the right side of the main show notes pages to get you to the various providers of audio content that carry the QSO Today podcast. Until next time, this is Eric for Z1UG73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.